February 16th through the 19th, lesson 24, multiplying and dividing rational expressions. So we spent last lesson talking about what a rational expression was. Now we're going to spend time looking at how to multiply and divide those. Alright, so our goal is to be able to multiply and divide rational expressions and to simplify using equivalent expressions. Alright, so the first thing I want to do is I want to talk about how we would model this expression, 2/3 times 4/5. Alright, how would I model that? Well, normally if you guys were in here, I would give you a note card or, a Post-it something and tell you to model this. So the first thing we would do is we need to represent 4/5. Alright, so I'm going to represent 4/5 this way. Alright, and we'll do 1, 2, 3, 4. No, well, mine's not perfect, but that's okay. And we're going to shade 4 of those. We're representing 4/5 here. Alright. Now we need to find 2/3 of the shaded area. So we've got to divide it into thirds. Okay? So now what I'm going to do is I'm going to shade it this way. So 2/3 of that area would be like this. Alright? And so the area that is shaded for both parts would be the answer to our question. Alright? So how many do we have? We have 5, 10, 15. And how many are shaded twice? 2, 4, 6, 8 of those. So we would have 8/15. Alright? So with this in mind, we're going to create a general rule for multiplying expressions. So think about this. If I am multiplying A over C times B over D, my rule is to multiply A times B and to multiply C times D. Alright, now the one thing we know is that C cannot equal 0 and D cannot equal 0 because we can't divide by 0. Alright, this rule is also valid for real numbers. If you remember how to actually multiply fractions, 2 times 4 is 8, 3 times 5 is 15. Okay? Alright, so let's look at example number 1. Make a conjecture about the product x cubed over 4y times y squared over x. What will it be? Explain your conjecture and give evidence that is correct. Guys, remember a conjecture is just basically an answer, a statement. Alright? So what would we begin by doing? Well, we would begin by multiplying the numerators and the denominators. So x cubed over 4y times y squared over x, we're going to multiply that. Alright, so x cubed times y squared is x cubed y squared. And 4y times x is 4xy. Okay, or 4yx. It doesn't matter which order you put those in. So now we're going to identify the greatest common factor of the numerator and the denominator because we need to simplify it. They both have what in common? Well, they both have an xy in common. So let's pull that out. So when I pull an x out of here, I have 2 left over, so x squared. And when I pull a y out, I have 1 left over. And then then down here, when I pull an xy out, I have 4 left over. All right, so here's what I have. So now we divide the common factor xy from the numerator and the denominator to find the reduced form. So when I divide xy by xy, I get 1. So what's left is x squared y over 4. Okay? Notice you did not hear me saying cancel out the x and y or cancel the common factor because we're actually showing division. They don't cancel. All right? We want to show that we're actually doing division here. All right. Let's look at example number 2. Find the following product. So it's telling me to multiply. Okay, so the first thing we're going to do, maybe we could factor out something. We want to make this as simple as we possibly can. So let's look at this. 3x minus 6. I can pull out a 3. So when I do that, I get x minus 2. All right, let's pull out a 2 from the bottom, and I get x plus 3 times. All right, I can pull out a 5 on the top, and that gives me x plus 3. And I can pull out a 4 on the bottom, and that leaves me x plus 2. All right. So now, here's what I can do. I can go ahead and multiply my whole numbers. So 3 times 5 is 15. And I get x minus 2 times x plus 3 over 2 times 4 is 8 over x plus 3 times x plus 2. The reason I did it this way is because you will see you have a common factor on the top and the bottom. All right, x plus 3 is a common factor. So when I divide those are 1. So I end up with 15 times x minus 2 over 8 times x plus 2. All right, and you can leave it in that form. Simple as that. You do not have to factor anything or do any kind of distributive property there. All right. So let's look at example number or exercises 1 through 3. Summarize what you have learned so far with your neighbor. All right, so I'm going to give you that for homework. You don't have a neighbor. I just want you to summarize what you know. All right, what have we learned so far? Find the following product and reduce to lowest terms. All right, so if we're trying to reduce to lowest terms, the best thing for me to do is to see if there's anything I can factor out. Well, if I look at the top, 2x plus 6, I can factor out a 2. So that leaves me 2 times x plus 3. This one, I'm going to see if I can actually factor it, which I can, x and x, and it's a plus minus, so I want to be able to subtract my factors of 6 to get 1. So I'm going to use 3 and 2, and because I want a positive 1, my biggest is going to be positive. All right. X squared minus 4. I can go ahead and factor that. It is the difference of two perfect squares. So that would be x, and 2 and 2. One's going to be positive. One's going to be negative. And then I have 2x on the bottom. Okay? All right. So now let's go ahead and multiply. I get 2 times x plus 3 times x plus 2 times x minus 2. All right, and then I get 2x times x plus 3 times x minus 2. All right, so I can look at this, and look, guys, 2 divided by 2 is 1. So I'm going to kind of mark those out to show that I've got 1 there. Alright, it's not to show that I canceled. Alright, x plus 3 divided by x plus 3 is 1. And x minus 2 divided by x minus 2 is 1. So look what I have left. I have x plus 2 on the top, and I have x on the bottom. And that is in simplest form. Find the following product and reduce to lowest terms. And it says they want us to do 4n minus 12 over 3m plus 6 to the negative second times n squared minus 2n minus 3 over m squared plus 4m plus 4. All right, so let's see what we can do with this. Guys, if you remember, when I have a negative exponent, in order to get rid of that, in order to change that, I would take everything on the top and take it to the bottom, and everything from the bottom, take it to the top. So I can flip that to make it a positive exponent. All right, so I'm going to rewrite this as 3m plus 6 over 4n minus 12 squared times, and I don't have to change anything on this one, minus 2n minus 3 over m squared plus 4m plus 4. All right, so I'm going to see what I can do to simplify this the best that I can. Okay, so I'm going to pull a 3 out. Now, when I do that, remember that 3 is squared because I have to square that whole entire thing. So when I pull that 3 out, I get m plus 2, and that's also squared. Over, I can pull a 4 out on the bottom, and I get n minus 3. All right, times, let's see if I can factor this. All right, so I can, n and n. It's a minus minus, so I want to be able to subtract my factors of 3 to get 2. So 3 and 1. I want a negative, so my biggest number is going to be negative. Over, and I'm going to factor this. M and M. All right, it's a plus plus, so my factors of 4 need to add together to give me 4. So plus 2 plus 2. All right. Now let's go ahead and simplify it the best that I can. Or go ahead and multiply, I'm sorry. So I get 3 squared, which I can go ahead and square that out. That is, and I'm sorry, I forgot to square these two. That's my bad. I forgot to do that because the whole entire thing is squared. So 3 squared is 9. And then I have m plus 2 squared times n minus 3 times n plus 1 over 4 squared is 16 times n minus 3 squared times m plus 2 times m plus 2. All right, let's see what I can do to reduce that. All right, 9 and 16 won't reduce, but let's look at this. So m plus 2 is squared, which means I have 2 of them. I have 2 of them on the bottom, so if I divide 2 by 2, I get 1. So those divide out to 1. N minus 3, I have 1 on top and I have 2 on the bottom. So I can divide one of those out. So I end up with 9 times n plus 1 over 16 times n minus 3. And that is in simplest form. All right, I want you to remember that division of numbers is equivalent to multiplication of the numerator by the reciprocal of the denominator. So in other words, when I have say I want to take 1/3 divided by 4/5. All right. Remember the rule, keep, change, flip. So 1/3 times, and I flip. I take the reciprocal of that second number. Okay? So then I would do what with it? Well, I would multiply it through. So I get 5/12. Okay, so we have a rule here. Let me kind of talk about it just a minute. So when I have A over B, that is the same thing as saying A times 1 over B. All right? B cannot equal 0, obviously. All right? So if I have 3/5 divided by 4/7, according to our rule above, what I would do is that would be 3/5 times 1 over 4/7. All right? That would be the same thing as 3/5 times 1 over 4/7. But what that means is, so if x times 4/7 is equal to 1, then I would get 4x is equal to 7, which means x would be equal to 7/4. So that's just showing you why we take the reciprocal of that. All right? So we take the reciprocal of that. So we have 3/5 times 7/4 would be 21/20. All right? So same thing with expressions. All right? It is the same thing with expressions. So let's go on and look at example number 3. Find the quotient and reduce to the lowest terms. All right, so let's look at this. I'm going to rewrite this as x squared minus 4 over 3x times 2x over x minus 2. So I'm going to just rewrite it. All right? All right, so then let's talk about this. I have the difference of two perfect squares. So one's going to be positive, one's going to be negative. Over 3x times, nothing I can do there, and nothing I can do here. So now let's go ahead and multiply. I have 2x times x plus 2 times x minus 2 over 3x times x minus 2. All right, look what happens. They divide and equal 1. Look at my x. My x's also divide and equal 1. All right, so I end up with 2 times x plus 2 over 3. All right, so therefore I have that for example number 3. All right, let's look at exercise number 4. Once again, quotient. So x squared minus 5x plus 6 over x plus 4. I'm going to change that to times, and then I'm going to flip it. X squared plus 5x plus 4 over x squared minus 9. All right, let's go ahead and work it out. Can I factor the top? I can. I get x and x. I want my factors because it's an x, it's a minus plus. My factors of 6 should be added together to give me a -5. So -3 and -2. All right, and then I have x plus 4 on the bottom. Times, let's see if I can factor this. I get x and x. It's a plus plus, so I'm going to add my factors of 4 to get 5. All right, and then I'm going to factor the difference of two perfect squares. So I have x plus 3 and x minus 3. Now let's just multiply together. So I get x minus 3 times x minus 2 times x plus 4 times x plus 1 over x plus 4 times x plus 3 times x minus 3. Alright, x minus 3 and x minus 3 divide out to give me 1. X plus 4 times x, or divided by x plus 4 is 1. So I end up with x minus 2 times x plus 1 over x plus 3. And that's my answer. Alright, look at this, guys. This is called a complex fraction because I have a fraction as my denominator. Even though we don't really look at it as a fraction, it's a fraction like my denominator. Alright? So, really, I can rewrite this as a division problem. And all that's saying is x plus 2 over x squared minus 2x minus 3 divided by x squared minus x minus 6 over x squared plus 6x plus 5. Alright? And so therefore what I can do is I can work this problem out. So I get x plus 2. Let's factor this one. I get x and x. I want to be able to subtract, so 3 and 1. Alright, I'm going to change it to multiplication, and then I got to flip it. Alright, so I'm going to factor this on top, x and x. 5 plus 1 is 6. Alright, now I'm going to do the bottom, which is x and x. And then 6 and 1. Nope, that won't work. Because I need to be able to subtract 6, my factors of 6 to get 1. So I'm going to use 3 and 2. And I want a negative 1, so the 3 is going to be negative. Alright, now let's multiply. X plus 2 times x plus 5 times x plus 1 over x minus 3 times x plus 1 times x minus 3 times x plus 2. Alright, x plus 2 divided by x plus 2 is 1. X plus 1 divided by x plus 1 is 1. So I get x plus 5 over x minus 3 times x minus 3. And I can rewrite that as x plus 5 over x minus 3 squared. I won't count it wrong either way. Alright? Guys, if you have questions, please make sure you reach out to me. I hope you have a great rest of your week.